Welcome back to this channel for practice problems for actuarial exams. My name is Krzysztof Ostaszewski. You can find information about me at smarturl.it/Jedi. My advice on how to pass actuarial exams is at smarturl.it/pass. I direct the actuarial program at Illinois State University. You can find information about it at smarturl.it/actuary. If you would like to make a tax-deductible donation to support our students, please go to smarturl.it/help-ISU-actuary. Here's problem number 11 from the last exam MLC, multiple choice section. For a 20-year term life insurance of $100,000 on a 45-year-old, you are given that the death benefit is payable at the moment of death. Mortality follows the illustrative life table. Delta, the force of interest, is 5%. Deaths are uniformly distributed over each year of age. Calculate the 95th percentile of the present value of benefits, random variable for this insurance. Now please note that the interest rate is not 6%. The force of interest is 5%. We don't know exactly what the interest rate is, but it's not going to be 6% if the force of interest is 5%. So the only thing we can use from the illustrative life table are the numbers that correspond to population size or mortality, but not actuarial present values of life insurance or life annuities, because calculations of those assume 6% in the illustrative life table. The present value of benefits random variable for this insurance will denote by Z, which is standard notation, and T, as always, denotes the random future lifetime of the person that bought the insurance. So the person got it at age 45 is 100,000 times e to the minus delta t, if t is less than or equal to 20, and 0 otherwise. And then, based on the data in the illustrative life table, the probability of survival over 20 years is L65 divided by L45, and that's about 82.22%. And that means that Z is equal to 0 with probability 1 minus that, which is about 17.79%. Now Z and T for life insurance are inversely related. This means that Z equals 0 corresponds to about 17.79% of largest values of T, and the 95th percentile, that Z equals 0, by the way, is the smallest value of Z. Other values are positive. And the 95th percentile of Z corresponds, therefore, to the 5th percentile of T. So T 0.05 such that probability of T is less than or equal to T 0.05 is 0.05. Or, equivalently, that means that probability that T is more than T sub 0.05 is 0.95. And that would mean that the population size at age 45 plus T 0.05 divided by population size at age 45 is 0.95. But we can look up the population size at age 45 in the table. It's 9164051, the same value we just used above in the calculation. And so the population size at age 45 plus T 0.05 must be 8,705,848.45. This lies between the population size at age 54, which is 8,712,621, and L54, which is 8,640,861. So that age, 45 plus T 0.05, is somewhere between 54 and 55. But we also are told that the uniform distribution of deaths assumption applies. And thanks to that assumption, we can find 45 plus T 0.05 through linear interpolation. That age is going to be 54 plus whatever fraction the difference in population size between 54 and 45 plus t.05 is as a fraction of the whole change in population from age 54 to 55. Because we can just take that fraction because the length of time between ages 54 and 55 is just 1. So it would be actually that fraction times 1, but multiplying by 1 doesn't do anything. It just leaves the fraction. And that is approximately 54.094378. Well, that means that t.05 is 54.094378 minus 45, so it's 9.094378, and the 95th percentile of z is 100,000 times e to the minus 0.05 times t.05. Now the first 0.05 is the force of interest. The second subscript 0.05 corresponds to the probability of 0.05. Well, then we plug in that quantile of t.05, which we just figured out to be 9.094378, and we do the calculation, and we get 63,462,634, and that's answer C. Please remember that this is copyrighted material. The problem itself comes from Society of Actuaries. The solution is mine. Good luck in your studies and good luck on the test.